So I'm going to go ahead and do questions 9 and 10 now. Remember, the directions said to evaluate the integral using integration by parts. Now, so I don't have a run out of room kind of mishap again. What I went ahead and did is I wrote these problems on another sheet of paper and wrote down my formula, the integration by parts again, just so I don't forget what I'm doing. So what I've got right now is we're going to go ahead and do number 9, which is the indefinite integral of ln of x, all of that squared dx. Now, I have a feeling someone's going to try to do a u substitution on this question because you would think, hey, I can use a u on that ln of x and do the squared as part of the u substitution. However, that's not going to be very helpful because if you think about it, in order to do a u substitution, we have to have the derivative of u in the problem. Well, the derivative of the natural logarithm is 1 over x, but I don't have 1 over x in this question. So the only really good way to do this is by integration by parts. And so in this case, the question becomes, what is the integration by parts that I'm going to use? Well, the integration by parts that I use, the u and the v that I chose are very, very specific in this case. So what I chose in this instance was, because this ln of x actually kind of disappears as we go along because we end up getting 1 over x, I'm going to use that as the u in this case. And the v prime I'm going to use is actually going to be 1. And that's actually a pretty common trick that happens a lot with... if you notice, I did something like this earlier with the inverse tangent formula. Because when I do this, I actually get a nice pretty fraction out as the answer, as its derivative. Think about the chain rule here for a second. And so that's actually going to be pretty helpful, whereas this v prime, if I do it this way, when I integrate that 1 dx, it's just going to turn into x. And so this x over here from the v and the 1 over x here from the natural logarithm are actually just going to kind of cancel out and make my life a lot simpler. And so that's something to think about. So the hard part with this one is just going to be picking my u prime, or my u and my v prime, so that things work out nicely. So again, we need to take the derivative of this. So power rule means pull out the 2, write it as times the natural logarithm of x, and then I still need to do the chain rule, which is times the derivative of the natural logarithm of x, which is 1 over x. So if I wanted to write it and make it look a little bit prettier, we would write 2 ln of x over x. Now again, come back over here to this formula and think for a second and say, hey, what am I actually writing down as the rest of the problem? So I've got to do u times v, so u was that ln of x squared, times v, which we found was x. And when I write my u prime, I'm going to write my dx on the end of it. So minus the integral of u prime, which is that 2 ln of x over x dx, times v, which was just x. Now, like I said, notice this is going to work out nicely. So this x on the bottom and this x on the side, they're just going to cancel out. They're going to disappear and make it so it's 2 times the natural logarithm of x. So I've got out front x times ln of x squared minus, and I'll move that 2 outside of the integral, times 2 times the ln of x dx. Now, we've actually done this question before where it's the integral of ln of x. And so that's kind of an important thing to think about, is this is a very common problem that comes up during the integration by parts, which is in itself an integration by parts question. And so I'm actually going to have to treat it very similarly to the way I just did it. So this is going to be integration by parts twice. So the integration by parts that I'm going to do here is I'm going to use u is, again, ln of x, and v prime is 1 dx. You could have also made it 2 dx. It's not going to really make a whole lot of difference here. The way I'm doing it now, it's just going to have a 2 as a coefficient on the outside. It's going to have to get distributed across everything. So if I take u prime, in this case, the derivative of ln of x is just 1 over x. If I integrate the 1 dx, I better remember to write my dx there. We've got v equals x. And so let me go ahead and write this down. So we've got, again, this x times ln of x squared minus 2 times everything that I'm about to do. So again, this is another integration by parts thing that I'm getting ready to work on. So what I've got to do is I've got to do u, which is the ln of x, times v, which is x. So let me write that down, ln of x times x, minus the integral of u prime, which is 1 over x dx, times v, which is just x. Now again, those are going to cancel. So we've got 1 dx in that integral, which is going to help my simplification in the end. So let me write this down again. So we've got x times the ln of x squared minus 2 times that whole quantity of ln of x times x, which I'll rearrange as x ln of x, minus the integral of 1 dx. Now, again, it's kind of important that we write that dx there so I don't forget what variable we're using, which in this case is x. So let me go ahead and integrate that. So we've got x ln of x squared minus 2 times that big quantity of x ln of x minus, remember the integral of 1 is just going to turn into an x. And so I'm going to distribute the 2. We'll do x times ln of x squared minus 2x ln of x. Don't forget to take that negative with it, so it's going to turn into a positive 2x. And the only thing I still need to do at the end, if I'm remembering everything correctly, is to do the plus c, the integration constant. And so my final answer here is x times ln, or the natural logarithm of x squared, minus 2x times the natural logarithm of x, plus 2x plus c. So final answer right here. Notice again, this was a little bit more of a challenging problem, but it is important to notice again, both times when I was dealing with this natural logarithm, that natural logarithm was my u, and my v prime was actually just a plain old 1. So now that I've got number 9 handled, we're going to go ahead and move on to number 10. Very similar kind of problem, which is we've got the integral of ln of x over x squared dx. Now, in this case, and I'm going to think about this kind of very carefully, I don't really like this fraction here, this x squared. And so, in order to make my life a little simpler, what I'm going to do is I'm going to rewrite it ever so slightly in a way that you guys I know are familiar with. We're going to write this as x to the negative 2 times ln of x dx. Now, if you think about this x to the negative 2, if I take its derivative, is not going to get prettier. It is only going to get worse the more I take its derivative. So I don't want to use that as my u. I would much prefer taking this ln of x, which ln of x right now is actually going to turn into something simpler if I take its derivative. So that's an important thing to think about, is if you've got a natural logarithm of x in your integration by parts, it's a good idea to choose that as your u, like we said in the last problem. So again, I'm going to choose my u to be ln of x. That way, when I take its derivative, when I find u prime, it's just 1 over x dx. Now, that being said, if I make the v prime be x to the negative 2 dx, I need to make sure that I integrate that properly. So hopefully you guys remember, if we take the integral, not derivative, but integral. So that exponent is going to go up by 1, so it's going to be x to the negative 1. And I'm going to end up dividing by that new exponent. So I'm going to divide by negative 1, which just makes that negative. Okay? So I've got negative x to the negative 1, which you could also write as negative 1 over x, whichever one makes you feel a little bit more comfortable. But now that I've got that set up, I can go ahead and work with my formula. So I'm going to do u, which is ln of x, times v, which is that negative 1 over x. Then I'm going to subtract the integral of u prime, which is 1 over x, times v, which is negative 1 over x dx. Okay? So now that I've got that taken care of, I'm going to go ahead and kind of make that look a little bit simpler. So that's going to be a negative natural logarithm of x over x minus... there's a negative in there, so I'll actually just make that plus the integral of 1 over x squared dx, which again, you could go back up and write that as x to the negative 2. The good thing is we've already found what the integral of x to the negative 2 was. We wrote it up here because notice v prime was x to the negative 2, and we wrote v as negative x to the negative 1. So I have negative ln of x over x. And then we've got, when we take the integral of 1 over x squared, which again was x to the negative 2, we're going to get negative 1 over x. Okay. And so if you wanted to, since they have a common denominator, that might be helpful to write it as negative ln of x minus 1 over x. There's a couple of different ways you could write this. That's one option. Another option you could write it as is negative and then use parentheses. So you factor out the negative ln of x plus 1 over, I'm running out of ink, over x. But either way, you still need to remember to put your plus c, your plus constant at the end. Okay, so a couple of different answers that are all acceptable. I'll go ahead and circle my final answer. So here's one final answer that is correct. And here's another final answer that's also correct. Like I said, there's a couple of different ways you could also write this. I would honestly even accept this one as long as you remember to put your plus c at the end. But hopefully that helps you guys get a better understanding of what to do with these integration by parts questions. Again, the big thing that I wanted you guys to figure out about these last couple of problems is that if you have a natural logarithm in your integration by parts, probably a good idea to use that as your u. Have a great day.